Okay, I accidentally ended the previous recording sooner than I meant to, but that's okay. So the first video is a little shorter than I wanted to be. So now let's get to some basic rules. So our first basic differentiation rule. The derivative, d dx, the derivative of c is 0, where c is a constant. In words, the derivative of a constant is 0. Now we're not going to prove a whole lot of things in this class, but here's a proof. Let's let f of x equals c, and let's find f prime of x. Well, the only tool we have in our derivative chest right now is the definition of the derivative. So the limit as h goes to 0 of f of x plus h minus f of x all over h. So that's the limit as h goes to 0. So we have the function f of x equals c. What that is saying is f of anything is c. That f of 2, f of 12, f of 19, f of negative 3.21796 is c. F of everything is c. That's the way a constant function works. It stays constantly whatever the value is. In this case, c. So f of x plus h is c. F of x is c all over h. Well, that's the limit. Let's go over here. That's the limit as h goes to 0. Excuse me. Of 0 over h. That's a 0 there. Which is the limit as h goes to 0, 0, which is 0. So you don't have to be able to prove it by any stretch of the imagination, but we now know that the derivative of a constant is 0. So an example here, the derivative of 123 is 0. Next rule, the derivative of e to the x is e to the x. And you're just going to believe me on that one. We're not going to prove anything. You're just going to trust me on it. And so in words, the derivative of e to the x is e to the x. E to the x is its own derivative. Now please note, the derivative of e to the 2x is not going to equal e to the 2x. The derivative, if the exponent is something other than a simple plain variable, x, t, p, q, whatever letter you want to use. Remember, e is a number. The only thing that's the derivative of e to the x is e to the x. Derivative of e to the t is e to the t. The derivative of e to the q is e to the q. But once I change that to something other than a simple plain variable, like e to the 2x, there is a change in the rule that we need to use for the derivative. So right now, all you know is the derivative of e to the x is e to the x. Derivative of e to the t is e to the t. Derivative of e to the y is e to the y. But you don't know the derivative of e to the x squared, or e to the x cubed plus 5. You don't know those derivatives yet. Then a rule that we're going to use a bunch, the power rule. If n is any real number, then the derivative of x to the n is n times x to the n minus 1. In words, to differentiate a variable raised to a numeric exponent, multiply by the exponent, and decrease the exponent by 1. Please note, very specific here about the form that we have here. A variable raised to a numeric exponent. That's the only form we're talking about here. Up here, you had a number raised to a variable. There's one form, and then we learned specifically when it's e to the x, that very specific form, the derivative is e to the x. Now we're talking about the very specific form, a variable raised to a numeric exponent. And by variable, we mean just a single variable, x, y, p, q, t, whatever your letter happens to be. So over here, we're going to have some given functions. Then we want to write the derivatives. So we're going to use my rule. So the derivative is going to be multiply by the exponent, decrease the exponent by 1, and so we get 4x cubed. None of you are probably going to show this step, and I'm not expecting this step. But it demonstrates what the step is. Multiply by the exponent, decrease the exponent by 1. Same thing here, but let's be real specific. That's x to the first So doing the same rule, multiply by the exponent, decrease the exponent by 1, then simplify and get x to the 0, and now we want to simplify everything, and if there were some actual people in the room here while I talked, I'd say, what is anything other than 0 to the 0 power? And anything except the number 0 to the 0 power is 1, so I get 1 times 1, or 1. And so what you just want to remember is this, is that the derivative of x is just 1. You're not going to go through all those steps each time. Just remember that the derivative of x is 1.